Hi guys, today we're going to talk about water, the role it plays in the body, and how to optimize it for athletic performance. So, why is water so important? Water is the most abundant molecule and major constituent within the body. Water is essential for cellular homeostasis. It transports nutrients to cells and removes waste away from cells. It also acts as a medium in which all transport systems function, allowing for the exchange between cells, fluid spaces, and capillaries, a process known as osmosis. Water also acts as a lubricant in one's saliva, digestive tract, and respiratory tract. Furthermore, it can act as a shock absorber for joints during walking or running. It also plays an important role in the protection of the brain and spinal cord. The differences in physical properties between the intracellular and the extracellular water distribution is dependent on the presence of different major cations and anions. Around 65% is intracellular and 35% extracellular. The extracellular distribution is dependent on sodium, chloride, and bicarbonate concentration. And the intracellular distribution is dependent on potassium and inorganic phosphate concentration. So what are the two main states of hydration? Euhydration is defined as the normal state of body water content. This oscillates during the day due to water losses and gains. The other is dehydration, well known, and the process of water being lost. So with that in mind, what are the factors that affect our hydration status? Examples of intake would be drinking, of course, water from food, and the metabolic water produced during normal condensation reactions in the body. Whereas examples of loss would be fecal excretion, sweating, and of course, urination. So, with all that in mind, how does that affect athletic performance? Fluid replacement, and fluid, in terms of water and electrolytes, is questionably the most important dietary essential in maintaining exercise capacity. So why is the appropriate hydration so important? Water maintains blood plasma volume. It regulates body temperature and is crucial in the contraction of muscles. A loss of 2% of body weight due to sweat increases the risk of nausea, diarrhea, and vomiting. A loss of about 5% of body weight due to sweat can decrease work capacity by roughly 30%. Osmolarity is the pressure exerted by a solute in the presence of a semi-permeable membrane, which allows for free passage of water. This is determined by the sodium, chloride, and bicarbonate concentration I spoke of earlier. The optimum plasma osmolarity is 275 to 299 milliosmol per kilogram. Drinking fluids with the appropriate electrolyte balance is optimum for hydration during prolonged exercise. Drinking water alone during an ultra-endurance event, for example, can lead to an increased risk of hyponatremia. This is when the sodium concentration falls below 135 millimole per litre, increasing the need to urinate. This is due to the blood plasma volume increasing and making it hypotonic. So, how does it work? Let's focus on the blood, your temperature, and muscles. So, the blood. Dehydration will lead to increased blood viscosity. That's the blood thickness. This is due to the decrease in blood plasma volume, and thus reducing the volume of blood returning to the heart and consequently decreasing cardiac output. In short, one's ability to get oxygen and much needed nutrients to the muscles at work are massively hindered. Next, we'll go on to temperature. An increased core body temperature can lead to an increased glycogen breakdown, contributing to a faster rate of fatigue. The breakdown of glycogen is largely responsible for the buildup of lactic acid, lowering the pH of the muscle, again causing further levels of fatigue. Next, we'll go on to muscles. So a study at the University of Connecticut was conducted on athletes' hydration status and their muscle growth during resistance training over a period of 3 different states: hydrated, moderately dehydrated at 2.5% body weight, and critically dehydrated at 5% body weight. Researchers drew the athlete's blood and examined certain molecules directly correlated with muscle growth. The athletes in a dehydrated state had increased levels of cortisol, a stress hormone, which reduces the levels of testosterone one can produce, one of the primary hormones required for muscle growth. So, how do we stay perfectly hydrated? Thirst is a poor indicator of one's hydration status. Once the sensation of thirst occurs, the body is already dehydrated. The simplest way to maintain an optimal hydration status is to observe the colour of urine. It should be pale or straw coloured. Any darker suggests a reuptake of fluid is necessary. So, what to drink in terms of plasma tonicity and cell response? We can break that down into isotonic, hypertonic, and hypotonic solutions. First, we'll start with isotonic. This is a solution similar to the electrolyte concentration to that maintained in the body, allowing for free flow of water in and out of the cell. The cells will generally remain the same size. Next, hypertonic. This is when a higher electrolyte concentration to that maintained in the body. Water will leave the cell, causing it to shrink. So, for example, in an ultramarathon, one could replace the high levels of electrolytes lost during sweat by consuming a hypertonic drink. But with that in mind, excess fluid or excess water consumption might be necessary to actually hydrate the body. Next, we'll go on to hypotonic. So this is a lower electrolyte concentration to that maintained in the body, thus causing water from the environment to fill the cell, causing it to swell or even cause cell lysis, which is when the cell bursts. This can be used to rapidly replace lost fluids. So when an athlete might require some water, but not necessarily electrolytes. So, in summary, water is a major component of many chemical reactions on a cellular level in the body, whether for athletic performance, focus, or for overall health. Research suggests that it is almost impossible to reach maximal physical performance when dehydrated, due to the impact it has on the body's ability to maintain osmotic homeostasis. Alright, thank you guys. Like, comment, subscribe, and if you have any questions, just leave them in the comments and I'm sure I'll get around to answering them.